We'll proceed in partial Jacobian in calculus. Partial Jacobian in calculus, that is something coming as very new. We are proposing partial Jacobian in calculus. What is partial Jacobian in calculus? What is the idea behind the Jacobian? The idea behind the Jacobian is to whatever we have integration in form of Cartesian coordinate, can we make our life easy by doing integration by substitution? Instead of doing everything in x, y, z, can I take x as a function of other independent variable, y as a function to other independent variable, z as a function to other independent variable. This is called integration by substitution. Like we calculated the voltage. If I have a RC circuit, resistance capacitor connected in series, and in series only they are connected to a voltage source Vs. What is the voltage at capacitor at any time t? Because voltage across capacitor will be zero at the beginning. When someone switch on this RC circuit, then voltage will start rising. It will be voltage will start rising because it will start storing the charge. Or in plain electronics terms, initially the resistance of the capacitor would be infinite, and slowly resistance would build up. Resistance of the capacitance at the beginning is zero, and slowly resistance would build up, and after some time it becomes infinite, and there won't be current flow. So at the beginning where resistance is zero, there will be steep current, it will flow, and slowly current would decrease and it becomes zero. Any moment, what is the current or what is the voltage across capacitor? Now the current across in capacitor, if I see the across the RC circuit, resistance and capacitor, across the resistance, the current is I. So at any moment, current at capacitor is also I. Voltage across resistance is R into I. So voltage across resistor and plus voltage across capacitor is the same voltage what we are supplying to the voltage source Vs. So Vs equal to voltage across resistor plus voltage across the capacitor. So voltage across resistor is I into R plus voltage across capacitor is V that we want with the with the with the time. Now V, a voltage across the capacitor, V equal to charge by capacitor. There is a capacitance terms comes into the picture. We will see it. So V equal to charge. How much charge the capacitor has stored? Dependent upon that, voltage will be generated across the plate of the capacitor. Voltage equal to charge by Q by C. dV by dt equal to 1 by C into dQ by dt. dQ, d charge by per time. Okay, how much the charge is getting stored per unit of the time. If there is a variation of 1 unit of time, how much of the variation in the charge we see? That is the current. So dV by dt equal to current by capacitance. Means if capacitance is very low, then dV by dt is fast. Immediately it will be charged, immediately it will be discharged. If capacitance is very high, then it will resist in flowing of the current. So dV by dt will be slow. So dV by dt inversely proportional to the capacitance. So dV by dt equal to current by capacitance. Okay. If that is the case, then current equal to capacitance into dV by dt. Now Vs, that is the voltage source, Vs equal to I into R, that is the resistance voltage, plus V, that is the capacitance voltage. Now current I is nothing but C into dV by dt. So RC into dV by dt plus V equal to voltage source. If that is the case, then RC into dV plus RC into, now V I can take that side. So RC dV by dt equal to Vs minus V. Vs minus V I can take this side, and RC I can take that side. So dV by Vs minus V equal to T by Rc. Now dt by Rc. Now if I integrate, this becomes a differential equation. If I integrate, I get the voltage as per the voltage as per the equation of time. So dv by Vs minus V equal to dt by Rc. Now dt can be integrated to t. But how to integrate dv by v? If it is dv by v, I can immediately say it is ln, natural log of v. But dv by vs minus v. Here method of substitution comes into the picture. dv by vs, or someone can just think how I can integrate dv by vs minus v, where vs is the voltage source, so that is constant, minus v. V is the voltage across capacitor and it is variable. Now someone can take vs minus v equal to x, then minus dv equal to dx, or dv equal to minus dx. Now that is minus dx, or numerator becomes minus dx by x, and then it becomes minus natural log of x minus ln x equal to t by rc, minus I can shift that side, ln x equal to minus t by rc. Now people would go, now what is the next I have to change? The limit. Earlier the voltage was from voltage started from the voltage across the capacitor. If we are integrating dv, then voltage across the capacitor, it starts from 0 to v. Initially the voltage is 0. Now at any time t it is v. That is 0 to v. But it is in x now, ln x. Now x, for that I have to change the limit. Let's see the part by part. First I went with method of substitution. Then I did the integration. Now I am changing the limit. Now x equal to vs minus v. If v is 0, then x is vs. If v is v, then x is vs minus v. So integration comes as v to vs minus v ln x. Now ln vs minus v minus ln v. ln vs minus v by v. ln would go that side, it becomes exponential e to the power minus t by rc. And here vs minus v by v. Okay, if that is the scenario, then someone can settle it down. Okay, I believe I made something wrong. While setting the limit, I'll change it again. X equal to vs minus v. If v is 0, the limit of v is 0 to v. If v is 0, then x equal to vs, and v is v, then x equal to vs minus v. So limit now is vs to vs minus v. It becomes ln vs minus v by vs. ln go that side exponential. So vs minus v, vs minus v, or 1 minus v by vs equal to e to the power minus t by rc. If I settle it down, then it becomes v by vs equal to 1 minus e to the power minus t by rc. V at any moment is vs, and in bracket 1 minus e to the power minus t by rc. If I see integration, there are three parts. One is called limit. Other is called integrand, and other is called differential. So in our limit is voltage 0 to v. This is linear limit, single dimension. And the integrand is 1 by vs minus v. Differential is dv. Now scenario comes is we cannot do integration. Integration is not that straightforward as the differentiation is. If that is the situation, then how we can proceed now? So we go by method of substitution and we change one, what is independent component here? V is independent component here because differential is dv. V is independent component here. What is the dependent component? 1 by vs minus v. Integrand is called dependent component function. Fv function over V equal to 1 by Vs minus V. So Fv dV integration limit of V 0 to V, three part of the integration. If I go integration by substitution, if I go integration by substitution, then integrand independent component is V. The integrand we change, we bring in new independent component. So if my independent component is V, then I am bringing new independent component as X. On V, there is a dependent component called Fv, function over V. Function over V, V X. Three things are coming into the picture. Function over V, Fv equal to 1 by Vs minus V. Fv is 1 by Vs minus V. And here the V and here X. V, Fv, function over V is dependent upon V. Where X is independent, V is dependent upon X. Indirectly, X is the most independent component. Now we are changing everything as a, now V is a function over X, and upon V there is a function over V, that is Fv. Fv is here, V is here. Now there is a function called G, that is Gx equal to V. Okay, now the idea is what we are trying to do. So we are trying to solve something. We are trying to solve something. What we are trying to solve something. If we see in terms of method of substitution, when we see integrand, our hairs are like that. Oh my God, what happened? This integrand, I cannot integrate. So we run for making it straightforward. What is straightforward? Straightforward is the limit what we are seeing, that limit, if it is not straightforward, it should become straightforward. We will talk about this. What is limit when it is not straightforward and when limit becomes straightforward? Here it looks straightforward because 0 to V is the limit. Straightforward means limit should be in constant. Limit should be in constant. Okay, not in variable. Right now limit is in variable, that is 0 is constant, V is variable. It should be some constant, but still it is very good. We will have kind of little bit, what you can say, something dirty when we see two-dimensional limit, but single dimension is all right. But we are integrand is complex. Vs means what it is complex, still we cannot do. Dv integrand is 1 by Vs minus V and differential is dV, that also we cannot do. Anyway, but idea is that we, if once we think about method of substitution, then we must think about the limit also. Limit, integrand and differential, all three would change. How we are changing all three things will go again one by one. Okay, V equal to function G over X. This is also called transformation. V equal to capital T and in braces X. So there is a transformation of X is happening and it is becoming V. Okay. Now dV is the differential. dV can be written as dV by dx into dx. So I have to, now I converted dV to dx. First conversion starts from differential. dV has to become dx. How it will become dx? dV equal to dV by dx into dx. Now it became dx, but extra thing dV by dx it is coming into the picture. It is called Jacobian. Okay. Now what is dV by dx? Okay. Now what is x? X equal to, what is x? Now we have taken x. So x equal to Vs minus V, or rather I can say V equal to Vs minus x. This is transformation function. This is actually transformation function. V equal to Vs minus x. So V equal to G function over x. V equal to Vs minus x, where V is the potential, the voltage across capacitor. Now dV by dx equal to minus 1. This is I am going to substitute there. Minus 1 dx. This is the new form now. Now 1 by Vs, now I have to settle integrand. 1 by Vs minus V, where V equal to Vs minus x. So it becomes x. So 1 by x minus dx. Now I have to settle the limit. So limit v is 0. The limit of v dv is 0 to v. When now v equal to vs minus x. So I'll change it other way. X equal to vs minus v. When v is 0, the lower limit becomes vs. When higher limit is v, then x becomes vs minus v. So vs to vs minus v. Now it is transformed. Okay, this is what people do. What people they do not do? What people they do not do is they can draw a graph in v plane. V function over v, that is 1 by vs minus v. This much is required. This is full-fledged method of substitution or Jacobian. Otherwise, anyone would hang anywhere. This hang is a software term where typically it comes from Windows where the machine hangs somewhere. So it won't respond. So if someone do not understand full-fledged, then there is a high time in three-dimensional, four-dimensional density function, it will hang. People would stop what to do. Okay, now I have now draw a graph for the v and function over v. Draw a graph and see the limit 0 to v. This section I need integration. Integration means calculation of the area. That is the integration. So fv, if I have x-axis and there is a curve line like this, then integration of this curved line along x-axis is the area down this curved line. If curved line is lying on the x-axis, whatever the hole you are seeing, that in the finger, that hole is the area it would calculate. But if curved line is above, this hole plus full down, full area it will calculate. Integration is nothing but calculation of the area. If that is the scenario, then someone can draw graph of 1 by Vs minus V. Limit is 0 to V and then see what is the area. Now, if I have taken a transformation function capital T, x, V equal to x, V equal to G function over x, or capital T function over x. If that is the scenario, if g equal to function, if v equal to function t transformation capital T and in brackets x, then now this is the v, this is the v independent plane, and now I am bringing x independent plane. The relationship between v and x is function over x, that is capital T x, capital T small bracket x bracket close. So that is the relationship. If that is the relationship, then someone can draw xv graph where x is independent component x-axis and y that is dependent component, that is capital Tx. Now he can draw graph there. Now graph is ready for v and function over v. Graph is ready for the x and function over x, that is v. Now this is v function over v graph. This is x function over x graph. Now whatever the graph I am seeing here, now as for the transformation, the graph is required here. Draw the graph here. And whatever the limit I had set 0 to v in this graph, see that limit how it transforms here. And then see what is the area we are going to calculate. That is the area we will get in x, capital Tx, or x function over x. This is what we are going to do. Partial Jacobian. That is the concept of the discussion. So anyway, now we will proceed with the partial Jacobian. Now I'll take example of a sphere and I have to calculate sphere. Okay. For the sphere, I need to calculate the kind of, let's try with the surface area of the sphere. So surface area of the sphere, if I have for the sphere, if I have xy plane, if I have a xy plane, then there is a sphere. So sphere, this is my sphere. Okay, now this is origin. This is xy plane. This sphere is centered at the origin. So if this is xy plane, now this sphere is going inside it and it is stuck at the origin. Upper part of this sphere called hemisphere, upper hemisphere is above the xy plane and the lower hemisphere below the xy plane. It is centered at the origin. Now, what is the full surface area of the sphere? Full surface area of the sphere is, if I take any position vector p at this sphere, then dp by dx, we have seen it many times. Please see past videos. It is explained in detail how to calculate the surface area of any shape. dp by, if I take any point p here, that point is x comma y comma z. If I say position vector, then position vector is xi plus yj plus zk. If that is the case, then dp by dx cross dp by dy, it gives the d surface by dxy plane. dp by dx cross dp by dy. How it gives? You have to check it. Because dp by dx is I plus dz by dxk. dp by dy is j plus dz by dyk. I plus dz by dxk is a vector in xz plane. Xz plane. Xz plane. And dp by dy, that is j plus dz by dz by dyk, is in yz plane. If I take these two vectors, one is in xz plane and one is at yz plane at any point p, then if I do cross product, it gives the area. That is the surface area. But this is velocity vector. dp by dx is velocity vector. So that case it is d surface area by dxy plane. Now if I want surface area, I have to multiply with the xy. So dp by dx cross dp by dy, dx dy or dxy plane is gives the net surface area. Now for the sphere, x square plus y square plus z square equal to a square. Z equal to square root of a square minus x square minus y square. dp by dp by dx cross dp by dy is minus dz by dxi plus minus dz by dyj plus k. Now I have to calculate magnitude of it. That's how area would come, because this is a vector. Calculus works with the algebra, not with the vector. So if I have d surface, this is dp by dx cross dp by dy vector. If I calculate the magnitude, this is d surface by dx by, this will give me this surface area magnitude by dxy plane. That I have, anyway I am integrating with the dxy plane. So d surface area by dxy magnitude becomes dz by dx whole square plus dz by dy whole square plus 1 square root. Now what is dz by dx? When z equal to square root of a square minus x square minus y square. That is minus x by square root of a square minus x square minus y square minus y by square root of a square minus x square minus y square plus 1. But this is dz by dx whole square. So x square by a square minus x square minus y square plus y square by a square minus x square minus y square plus 1 square root. That will settle down as a by square root of a square minus x square minus y square dxy means dx dy. Integration over a region, integration over a region in xy plane. What is that region? If there is a hemisphere, if there is a hemisphere that is centered at the origin, this hemisphere, if I see its print, its footprint you say, or its print, its shadow. On the xy plane, it will come as a circle. If there is a sphere also that is kept like this on xy plane, the sphere would go and map like like a circle in the xy plane. So integration is required for the circle. Why it is circle? Because if what is the shape? This is the 3D shape. 3D shape is nothing but a surface. 3D shape is nothing but a surface. So 3D shape is nothing but a surface. Then the surface, if this is xy plane, if this is xy plane and this is the surface, then surface can be very big. Which part of the surface I have to take? Or if this is the surface, then xy plane is very big. Which portion of the xy plane I have to take where the surface would map? Where the surface would map, xy plane is very big. That reason I have to do the integration, because x comma y and fxy, z. So z value I have to take from a certain region only, not full xy plane. I'll take the z value. That region is a circular region. In that circular region with the radius a. If I calculate fxy, that is z, it will resolve in a sphere. So I have to do integration in the circular region where radius is a. If that is the case, the circular region, now circular region, it is a circular region. It is not rectangle. So limit itself is difficult. The limit should be rectangle. Means on x-axis there should be a line. On y-axis there should be a line. Then we call it x, y are independent to each other. But x-axis is a line. If I take a circle here, then x-axis, if I take a line, straight line, then y-axis is a circle. Can you see it? If I take x limit as minus a to a, then y is a circle rounding it. So y is the square root of a square minus x square. It should be a rectangle. If it is a rectangle, then x is minus a to a, then y is also minus a to a or minus b to b. They are independent to each other. But since it is a circle, they are not independent to each other. As far as circular region it must be rectangular region. Now, if that is the case, if it is xy plane, and then I have to bring in another plane called uv plane or theta r plane, where the circle on xy plane should map to a rectangle, or I have to find a uv plane in such a way that the rectangle on uv plane would map to the circle in xy plane. I have to find the transformation function so that this rectangle should map to a circle here. Now computation will happen through this plane. This plane will shut down because I want limit as a rectangular. So that limit should be in digit, not in x is minus a to a and y is minus a square root of a square minus x square 2 plus a square root of a square minus x square. This is difficult. And then now integrand is a by square root of a square minus x square minus y square dx dy. Full headache. If that is the case, then what is the substitution? What is the method of substitution or parameterization, it is also called, so that we can take, so that it would solve the issue. Now there are two ways. One way is you take two-way parameterization. If there is an independent variable x and y, then take another as u and v. Now it is u and v plane, it is xy plane. If that is the case, then dx dy, that is nothing but dxy, small d bracket x comma y bracket close, dxy, it can be written as dxy by duv into duv. Now the duv becomes du into dv, that is the new independent variable, and dxy by duv, the way we did in the capacitance, dxy by duv, dv by dx, there dxy by duv, this is called Jacobian, but this is two-dimensional Jacobian and it is difficult. Can I solve it with single dimensional Jacobian, that is a partial Jacobian? That is under consideration. So for partial Jacobian, I won't take x, y and u be plane. One of them I will convert. This is our research. Okay. So you have to support us, or we will do something so that you have to kind of pay some royalty if you do in business purpose, and anyway you can use it. So our telephone number is plus 91 94831 60610, 94831 60610, plus 91 is country code of India. So please do support us. So this is partial Jacobian we will use. In partial Jacobian, dx dy both we will not convert to UV plane. One of them we will convert. So like I'll convert x, okay, or I'll convert y, I'll convert y. Let's go with the y. Y I'll convert to theta, another variable called theta. So dy can be written as dy by d theta into d theta. Now dy by d theta I have to calculate and do the, now accordingly change everything. Since we have not changed x, so x I can proceed upon. If that is the case, if it is a circle, then y then y I can take, x I can take minus a to minus a to a. I believe I am talking right. So y I can, so I'm sorry. Now limit is in circular region. Now it is x and y. I'll take y and x. The first limit I'll take as y, and inner limit I'll take as x. So y is, because I'm calculating x first. So y is minus a to a, and x is minus a square root of a square minus y square to plus square root of a square minus y square. If that is the case, now a by square root of a square minus x square minus y square dx, okay, that is dx that need to be calculated. Now what would be the dx value? Or I mean, I can try other way. I'm just trying to solve it is very difficult. So a by square root of a square minus x square minus y square. Let's try with the x first. Okay, let's try with the x. Now x equal to, I mean, this is what I'm saying. Okay, so x equal to the square root of a square minus y square, a square minus y square square root cos theta. Okay, let's proceed and then we will say what we did. So x equal to square root of a square minus y square cos theta. Now if that is the phase, then dx equal to dx. Now dx or dx by d theta equal to square root of a square minus y square minus sine theta. Now we have a by square root of a square minus x square minus y square dx dy. Now we will change dx, not dy. We are talking about changing dy, dx. Dx is nothing but dx by d theta into d theta. So dx by d theta, now here it is square root of a square minus y square minus sine theta. We will replace there. Now it is square root of a square minus y square minus sine theta, and then d theta anyway we have. So here a by square root of a square minus y square minus x square, x if I substitute square root of a square minus y square cos theta, then it will become a by square root of a square minus y square sin theta. Sin theta gone. Square root of a square minus y square gone, and it becomes minus a. Minus a I can keep outside. Now it is d theta, simple. Integration of d theta is theta. The limit is, x limit is square minus square root of a square minus y square to plus square root of a square minus y square. But limit is in x. Limit is in x. What about the limit is in theta? So limit in theta, now x equal to square root of a square minus y square cos theta. If x is minus a square minus y square, then theta is pi. If it is plus a square, square root of a square minus y square, cut down, then theta is 0. Now Can you see the difference now? This is what I wanted to show. Earlier, the integration limit is circular region where y is minus a to a and x is a square root minus a square root of a square minus y square to a square root of a square plus y square. And then this limit is a circular region where x and y are not independent of each other. It should be rectangular. Now we change into y theta. Earlier it was yx, now y theta, or xy, now theta y. In theta y, y is limit is minus a to a, theta limit is pi to 0. It is a rectangle now. Both are constant. Y is minus a to a. Y is if theta, if there was a xy plane, now we have theta y plane. Okay, in theta y plane, theta is x axis and y is y. Now theta is from pi to 0, from pi to 0, from pi to 0, or minus 0 to pi. Okay, and y is minus a to a. It is like it is forming a rectangle. This is what we want in the limit. So if you have limit, if limit is non-rectangular, then go for parameterization and make sure that it becomes rectangle. It is something like that I have something I I'm straightening. I'm straightening something like this. This is what is required in the integration. So that should be the aim. If there is a circular region should become a rectangular region. It becomes a rectangular region now. Now it is easy. Now, now cos theta, theta integration theta from pi to 0 becomes minus pi. Minus a is already outside, minus pi a. And now integration of dy y minus a to a 2a 2 pi a square. We talked about the upper hemisphere. Full is 4 pi a square. Okay, so this is partial Jacobian. Now anyone would take polar coordinate system. Now xy plane function over xy plane, and now xy plane is a function over theta r plane where x equal to r cos theta and y equal to r sin theta. And then they would proceed, and Jacobian, now Jacobian is dx by d theta. Now there it will become dxy by d theta r into dx d theta r. Now can you see the how much easy it is? We will proceed in the partial Jacobian and will see how far it will make our life easy. So partial Jacobian is our invention and we will proceed on it. Please support us. +91 India country code 94831606110. So we will proceed with the more example in the partial Jacobian, making use of Jacobian only in single dimension. Even we have two-dimensional independent component. So that we will see.